Okay, our guest speaker today is Christina Shay, Dr. Christina Shay. She's an assistant professor at the University of Oklahoma. I shouldn't have to read this, but I will. But she's a cardiovascular diabetes and obesity epidemiologist. She got her PhD at the University of Pittsburgh, where she did research. She did insulin clamp studies in patients with participants with type 1 diabetes. She and I actually worked together for those 4 years. And after she did her PhD, she went to Northwestern University and she did a postdoctoral fellowship there and on a training grant in cardiovascular disease. So that's where she got much more additional training in cardiovascular disease epidemiology. And she is heavily involved with the American Heart Association, especially in their activities for early career investigators like most of us. And she graduated in 2009 with her PhD. Since then, she's already had 18 publications, and she's a co-investigator in a cardio study. And today, she's going to be talking to us about how to get involved in several of the large epidemiology studies that we as epidemiologists like to work with.
Thank you, thank you. Yes, Bakia and I went through the dissertation madness together. We would spend many hours screaming at each other, well, not at each other, but commiserating together over our, now we look back as wonderful, but at the time wanted to kill him, dissertation advisor. So I'm an assistant professor at OU at the University of Oklahoma Health Sciences Center. And after finishing my PhD, I had this great opportunity to go to Northwestern, and they are a site for several of the large observational cohort studies. The nice thing about being at a site for these studies is that all of the data is in-house. You basically walk down the hallway and you ask somebody to cut you a data set. There's not the red tape to go through if you're not at a site, and you can just really get involved and learn how this process works. So that was one of the greatest aspects of my training during my postdoc time. And the presentation I'm going to give today is sort of what these cohort studies are, the benefits and the detriments to getting involved with them. They're really great resources to take advantage of, and how you can potentially use this for either dissertation work, master's thesis work, or even a springboard to develop your own career. So I'm going to talk a little bit about the studies themselves. I'm going to describe the concept of a population laboratory. That's sort of how I think about myself as a population scientist. I do have a laboratory, but it's basically my desk and a computer and conference calls, so that's sort of a different perspective for a lot of people. There's lots of opportunities for collaboration, whether it be for just manuscripts or additional funding and ancillary studies, so I'll talk about that process. How do you start at the bottom and get a collaboration started, just getting involved with the studies, as well as examples of how people have made this work for them in their careers. So I love this slide because as a graduate student or new in the career, or early on in the career ladder, I spent a lot of time figuring out exactly what I thought was interesting. What did I know? I was a graduate student. I think this is interesting. What I've learned more over the years to take advantage of are the opportunities that are out there. Nonetheless, I mean, you may not be all that excited about it or that interested in it, but sometimes having an excellent opportunity is worth a lot more than what you think is interesting. So taking advantage of those opportunities and really finding those bullseyes, whether it be in this capacity or however you can do that, try to make things work, the opportunities that are available for your advancement. Now, you can leverage a lot of your work onto the existing cohort studies. And here's a list of some of the advantages and the disadvantages. One of the main things that the funding agencies love about the cohorts, they do sink a ton of money into collecting these data. Millions of dollars go into collecting data, extensive data on thousands of people. However, when it comes to looking at every research question under the sun, it's a lot more effective to publish hundreds of manuscripts off of those few $1 million than it is to fund multiple investigations to look at individual questions. So it's very cost effective for them. They recruit lots of participants. Most participants come in for a study visit. They go through, say, a minimum of an 8-hour exam. They bring them in for breakfast, feed them, blood work, all the way through. They're doing testing and evaluation all through the day, and additional ancillaries are actually added to many of the studies where they come back for additional visits where they can actually get additional, let's say, scans or additional measurements that may just only be for a smaller group of people. So cost effectiveness is great, and it's also cost effective and efficient on your end too, because everything's already collected. You can get data sets cut for you depending on the data set, and you can take advantage of the existing resources. Like time efficient, they're available follow-up is oftentimes underway, so we've been collecting data. They've been collecting data on a lot of people over time, and some are continuing to collect data. Now, one of the best things, especially for early career investigators getting involved in these studies, we have to have publications. Publications are the currency in our field. You're not productive unless you get papers out there. And then on top of getting papers out there, the higher impact the paper, the better. So the one benefit to working with these cohort studies, because we have longitudinal data, we can actually look at temporal associations. Does this exposure occur before someone develops disease? And those types of temporal evaluations usually get bumped up into higher impact journals. So for you, it's nice because you get access to all of these data, as well as being able to answer questions that automatically sort of get bumped up into a higher impact journal. So it's good for both the study, and it's good for you to be able to look at some of these more interesting questions when it comes to what journals are interested in. Related to that, you can look at direct calculation of incidence and relative risk because of that temporal association. And the community samples, depending on where they're sampled and who they're sampled, they allow for study of many different diseases and outcomes. The caveat will be, depending on what disease you're interested in, there may be more or less data available. So the main focus of most of these cohorts is the development of cardiovascular disease and things that are related to cardiovascular disease. You'll have a lot of lifestyle data, but if you have, and diabetes in particular, because it's a major risk factor. However, if you're interested in something like cancer or a disease that, although we could argue that it's related, it wasn't necessarily the focus of the study, you may have a little bit more limited data in that area, but you kind of get that trade-off with, you may have, yes, no, this person has a history of cancer, but you get the benefit of a large sample of like 5,000 people to look in. So it's that individual level versus a population level of approach. But there are many CVD and non-CVD related outcomes and multiple exposures that you can look at. The major downfall to working with these studies is that because the data are already collected, you're going to be limited to what they did or did not collect. So I was having a conversation with some investigators here, and they were interested in a very specific thing that it's way outside of my area, but I'm just not sure if they ask questions about that. So when I'm finished here, I'll go through how you can figure out exactly what's available, and they just may or may not have those data available. So for example, in the diabetes world, everybody's interested in HbA1c now. Well, if you think back to a study that's been collecting data for 25 years, we only have HbA1c collected when people thought it was interesting to collect. So we don't have A1C back from baseline. We only started measuring it within the last, say, 10 years. People have gone back and wrote additional studies to pull those samples and run them, but say A1C may or may not be available back when they wanted to run it, or when they collected the data of it initially. Now, depending on your disease of interest, whether it's the disease itself or the prevention of the disease, you have to think about the numbers and the numbers of people you're going to be able to look at and the types of populations you're going to have access to. So if you're looking at prevention, when we look at everybody, most of these cohorts start with people who do not have disease at the beginning, and they follow them forward until they develop disease. Okay, so if you're looking at if you want to start with people that have no disease and follow them forward, you have probably the largest population to start from. As you get more into different types of disease or different levels of specific measure, your population sample will get smaller. So, for example, if you're interested only in people that have had a previous heart attack, you need to find cohorts that have a large proportion of people who have heart attacks in the sample. So, for example, one of the cohorts that I work with, they started at 18 to 30 years at baseline, and they're still following them forward 25 years later, but they're still only middle age. They don't have that many heart attacks yet. So that cohort in particular is not a good one to look at if you're interested in pulling out only those people who had heart attacks. We're kind of all sitting around and still waiting for these people to start having heart attacks. There's other cohorts that started with an older population, so when you look at the data, you're going to see a larger number of people that have developed disease or had heart attacks, stroke, heart failure, whatever. So you need to kind of first develop, the way that I usually work with students or investigators is, what is your research question in particular? What do you want to look at? A lot of people come to me and say, I want to work with this study. Well, that may not be the best study for you to look at your research question in. So first start with a question. I want to look at nutritional factors in people who have already had heart attacks, or I want to look at prevention in people that don't have disease and whether or not they develop it. If you figure out your question first, then you can identify the cohort study that will best be able to help you answer that question. So a lot of people take it from the opposite way. I want to work with cardio, what can I do? Well, that's sometimes a little less efficient than figuring out your question and moving forward to find the right data set. Now, this is by far not a complete list, but this is a lot of the major large observational studies that the National Heart, Lung, and Blood Institute has either funded or been involved with. These are mostly adult studies. For every adult study, there are probably additional, at least as many children's studies. So if you're interested in pediatric populations, I just happen to have the adult ones. But this gives you an idea of all of the different types of cohorts we have out here. The ERIC study here is a population, a mixed race, biracial population of 16,000 people at baseline. We have the CRDEB study, young adults at the beginning of early adulthood and following them forward. Cardiovascular health study, older population. We've got the classic Framingham heart study, and there's multiple Framingham spin-offs, Framingham offspring, Framingham. There's a bazillion different, their kids, their family members, they've looked at everything around these people. There's the Gokadan study here. This is genetics of coronary artery disease in Alaskan natives. So there's specific populations that have been targeted. The Hispanic health study, the study of Latinos. Jackson Heart study, that's an African American population in Jackson, Mississippi. The MESA study here is a multi-ethnic population. There's 4 race ethnicities: Caucasian, African American, Hispanic, and Asian. The Strong Heart study is a Native American population, also looking at cardiovascular disease and its risk factors. And then I'm sure most of you have heard of the Women's Health Initiative. Now, the Women's Health Initiative has both an observational arm as well as a clinical trial arm. So the observational data, if that's what you're interested from an epi perspective, those data are still available to look at. So this gives you an idea of all of the different studies. If you're interested in a certain group, comparing between 2 different groups, there's endless resources out there. And the interesting piece that people oftentimes don't think of, most of these studies, I'd say 90% of them are very open to collaborating with early career investigators, because at the end of the day, with the funding crunch that's going on, they need to make sure that they're getting papers out there and they're being productive, so that when they go up for additional rounds of funding, they can say, look what we're doing, here is why you need to keep giving us money to keep this study going. If they're not very productive and they're not getting new investigators involved, or if they have a very senior group of investigators but not a lot of early career people to take it over and move it forward, they're looked at as potentially one that's going to be phased out. So they really like to keep people involved, keep people, get people active in the research community, so that at the end of the day they can say, hey, we're being productive, give us more money to keep this going. For most of these studies, you have a very diverse populations that are available. And with regard to cardiovascular disease, they're very, very well phenotyped. You have all the different subclassifications of disease, different types of cardiovascular disease, stroke, heart failure, atrial fibrillation, anything you can think of. They either have it categorized at one time point, or they are going back to reclassify it. So for example, definitions have recently, not recently, but since it was collected, definitions for atrial fibrillation have changed. So there's new definitions of atrial fibrillation now in the current data sets, but people are going back to reclassify the old data based on the new definitions. So you have to also take a look at what's available when. If you're looking at something like the new definitions of AFib, you might only be able to do it now, but if you get involved in our patient, you may be able to get in on that when they complete it and be part of the crew that's sort of getting that going. Lots of data, more than you're probably going to even imagine, and there's so much that still needs to be done. They're followed prior to and for future events. This is a list of the most common events that they're following for CVD, MI, heart failure, AFib. They have procedural information, whether they've had stents or CABG or whatnot. Stroke and death, and they classify mortality, different types of mortality, so they detail that quite extensively. And the nice thing about these types of studies is that the events are all very thoroughly adjudicated and validated using standard criteria. And it's all been done for you. So when you get access to the data, what you really need to know is how somebody else has previously classified this, and basically, not to make this sound easy, copy and paste that into your methods section from what has already been done or how they did it. And honestly, these studies will send you exactly how they want you to list how events were adjudicated or whatever. So at least with the methods section, I found that it's oftentimes a lot of copy and paste. I'll contact an investigator. Hey Jeff, do you have details about how this was done? Copy paste. So it's a lot of, although there's a lot of responsibility on your end about getting these projects moved forward, what you do need to do is just absolutely make sure you know what was done, because sometimes it's a little easy to just keep moving forward without really knowing what was going on. From an ancillary perspective, or doing additional measures on your own that were not previously done, there's a very large stored specimen repository. Okay? There's available plasma, serum, DNA if that's something you're interested in, and various different genotypings have been done if it's of interest to the CVD community or something related, including GWAS if that's your thing. They often have additional in-person exams scheduled. Some exams, so for example, the CRDEB and the MESA study both are currently still following people up. Some have completed following people up, and there may be maybe they don't have in-person exams still scheduled, but they're still following participants with surveillance for events. So you might have clinical data only collected during a certain window, like the Strong Heart study falls in this category. They're not bringing people back anymore. Well, that's still debatable. We're still looking at funding. But let's say they stopped collecting data on them in person, but they still contact them regularly and keep in touch to see who has had events. So you might have clinical data up to a certain time point, but you can look at development events beyond that time point. The other nice thing about these studies is that for the most part, again, very, very seldom do you find individuals that work on this study who are not just the most wonderful collaborators that want to help early career people. They want their studies to do well, and they want people to use these studies as a platform for their own careers. Really wonderful people. I feel, now that I'm in a position where I have grad students and I'm giving feedback and I'm on the other side of that, it helps me appreciate how much time and effort these individuals invest in early career investigators that, hey, just called them one day and said, I really want to write this paper, would you mind being a co-author? And they're spending all of this time looking at proposals, looking at papers, abstracts, presentations, and they really do this out of the kindness of their heart. Now granted, a lot of them are funded for a certain amount of time on the study, so they do get paid in ways for doing it, but most of them are wonderful. And because they are, there's thorough processes that you have to go through, you get tons of feedback from really leading experts in the field. So by the time your papers go through the process to the point where they're ready to be published, it's been thoroughly vetted, and you know what you're going to get from a reviewer, you know what you're up against as far as the strengths and limitations for a given set of analyses. So this is my concept of a population laboratory. The cohort studies are themselves a population laboratory. I don't tell people that I have a lab, but that's sort of the way that you can think about it. It's really a crossroads behind where clinical research, community research, and lab-based studies come together. And depending on what research question that you're looking at it, that direction can, it's a bi-directional relationship. There might be something in a basic science laboratory that's being investigated, where the cohort studies can be a platform for getting your own funding or getting additional monies to look at something that's still investigational in stored samples from a cohort study, because you might be able to run some new assay or blood marker or whatever that you think is related to something new, and you benefit from all of the data that they've already collected on these people. Sometimes it's much more efficient than recruiting 30 or 40 of your own people, because you'll have to not only recruit them and run your stuff, your assays or whatnot, you'll also have to do all of those additional measurements yourself. So it's actually more efficient many times to get involved with these studies where you ask them, hey, I just need a sample of 70 people. They have stored blood. They'll probably let you do it as long as you get all the approval you need. And then they give you all of the data that they've already collected on these people, assuming that the samples are stable and you can run whatever you need. But that goes both ways. It can go from basic science to the population level. But if there's something that we're seeing at the population level, that can oftentimes be a platform for people in a basic science capacity to start testing observations that they see in a population level. So it oftentimes goes both ways. The two main ways that early career people, whether it be students or even junior or mid-career faculty or even later career faculty, can get involved. The easiest way to get involved, and usually the place where I suggest people start, is with publications. It's sort of, you build a rapport with the studies, they get to know you, they get a feel for you and that you're a good egg to work with. And then the next level is oftentimes ancillary studies, once you kind of get a feel for the study. Now that's not to say that you have to publish first and then you have to go through that first before you propose ancillary studies, but usually this is the way that it goes. It's not unheard of that people walk right in and say, hey, I've never worked with you before, but I want to write a grant and collect some more stuff on the people you're bringing in. But most of the time, publications is the first way to start, and that includes publications that can be used for master's thesis, PhD, dissertation topics, whatnot. We have several graduate students in our department who are using either a single data set for one master's level thesis, or I have a couple graduate students that are working in my department who are looking at a similar theme, using a 3-paper option for a PhD, looking at a similar theme but exploring it in different populations and using different methodologic approaches across multiple cohorts. So that's an option for graduate students and for early career investigators. Now, a lot of people tend to take a pessimistic view of these types of collaborative opportunities. Basically, oh, they're trying to get me. Some investigators are thinking, well, this is my area and my data and my stuff, and we don't want new people in here or whatever. This is absolutely not what the majority of the cohort studies are like. You may propose an idea and walk in the door and say, hey, I really want to look at this. Now, granted, if you have it, it's probably a good idea. Don't be upset if somebody else already has that idea and is working on it. But what you oftentimes get out of it is an opportunity to collaborate with them and potentially be a co-author on a paper that they're already working on. If it's in early enough stages, you can say, hey, is there room on that paper for me? I'd really like to be involved with that because I had a great idea. I like that idea. More than often, there's enough room, and if they're totally full up and they have enough people on it, they'll say, sorry, we don't have enough room. Most of the time, they'll add you on. You can kind of get a feel for the process in that way also. But another nice thing that'll happen is, I gave this example earlier today. I had a student that was interested in job-related stress and incident hypertension. Makes sense, right? If you're stressed on the job, do you have high blood pressure or higher rates of developing high blood pressure? Well, somebody else already had that idea because it was a good one. But when we contacted them and they said, we're already working on that. But one thing we haven't looked at, because this is their field, they're already thinking about all the stuff they're wanting to look at, right? We haven't looked at this in relationship to incident diabetes. So the student's like, okay, so I kill two birds with one stone. I get to be on this paper that I thought was a good idea anyway, and they let them take first author on this other paper because no one had started it yet. So there's lots of ways to get involved. Let's see. The other, and I've talked with some investigators here about this issue in particular, data using the existing information collected from the previously collected for the studies can be either part of a main study, and it's just based on, when we talk about the main study versus the ancillary, just to give you a little feedback, most of the main studies come from one type of funding source. The National Heart, Lung, and Blood Institute will agree to pay for these numbers of measurements, and this is what's considered the main study. Blood pressure, glucose, lipids, diabetes, whatever. This is the main study. Most exams have the main study variables Every time they came back, they got the main study variables collected. However, if people wanted to measure additional things, which is what we call the ancillary studies, sometimes they're sporadically sprinkled through whenever someone was either able to get funding or whenever they were interested in measuring it. So some things are available at all time points, some things are sprinkled throughout. But you can use either the main study or the ancillary study. You can look at just that cohort and ask a question, or if you have something going on, maybe a score that you've used to predict something, or something that you're looking at in a smaller data set, you can use some of these large studies to validate whatever you're looking at. Or let's say you're looking at something in an African American population. Do you want to validate it in a Caucasian population? Or do you want to validate it in a Hispanic population? So using all of this already collected data, you can use it in lots of different ways rather than just working with one data set. Now, you know, I thought when I was a graduate student, the hard thing for me was figuring out what the good ideas were. Now I know what all the good ideas, at least I have a better idea about what all the good ideas are. Now we don't have the time to follow up on all the good ideas. Okay, so you go through this time of, oh, I have to think of a good idea. When you get to a point where you'll find where you'll get to a point where, God, all of these are such great ideas, and people are asking, do you want to write this paper? Do you want to write this paper? There's just not enough time in the day for all of the investigators that are already involved to write all the papers, because these studies are huge reservoirs for publications, particularly CRDEB and MESA. And I'm going to focus on these two because these are the two cohort studies that I work with. Again, there are many, many unanswered questions, so I'm going to walk you through the process of looking at what's already been done, but don't get overwhelmed with all of the papers that are already done, because I promise you, even if there's a paper that was written that looked at 10-year incidence of something, guess what? We've been following people for 25 years now, so you can redo that same paper in just like 25 years of follow-up. So there's lots and lots of opportunities. But I put this in here, just don't be intimidated by the large amount, because there's always more to do. For example, if they haven't looked at racial ethnic differences, you can do that. The main areas that are really hot right now, especially because these populations are aging and starting to develop some of these conditions, predictors of heart failure and atrial fibrillation is a really interesting and hot area, microvascular and macrovascular diseases. Dietary factors, if you haven't ever gotten involved with dietary nutritional epidemiology, these are some of the major cohorts. You know, if you see in the news in the morning, you hear the new headline, new study shows that red wine is associated with, you know, red wine is now bad for breast cancer. These are these large cohort studies that most of these headlines come out of, so there's lots of dietary data if you're interested in that. Biochemical markers that have either been collected already, or samples that you could collect new biomarkers or measure new biomarkers, and all of the interrelationships between them. If you're interested in collecting additional data on top of what's already been collected and you want to go the ancillary route, these are proposals that collect additional data. The new data can be collected either by directly examining study participants if they are scheduled to come in for another exam, but you have to catch it with timing. So, for example, year 30 for CRDEB is going to happen soon, but because it takes at least a year to plan these, it takes more than a year to plan the exam itself and what's going to be in that 8-hour exam, you need to catch it at the right time to be able to be involved with the process of what gets put in that exam. So this isn't necessarily something that students are going to want to do because you want to graduate and get a job sometime. But as a faculty member, or when you're starting to become more of an independent investigator, this is something, if you time it right, you can get in on, and it can really boost your publication list as well as your ability to collect data using this already existing resource. With the stored samples, you can go back and process new samples depending on what you're interested in. Stored samples, it includes stored samples. That's what people most readily think about. However, there's imaging data that's been collected. So, for example, we have DEXA data collected on a lot of people. We have CTs done for abdominal adiposity. People are going back. They had earlier CT scans of the abdomen and of the heart. Now we're using new imaging technique to look at cardiac remodeling in the vessels that they didn't have when they did CT scans earlier. So people are going back and using the existing data that's in the scans. They're using new software to process the previous scans. So there's lots of different types of data that you can look back at. Imaging, medical records, lots and lots and lots of data. But the downside to the ancillary study is you usually have to get your own money to do them. So if you want to, like, I mean, it's possible for grad students. We do have a grad student in our department who secured a very small grant to run vitamin D samples, blood samples, in the Strong Heart study. She's doing that for one of her dissertation papers. I didn't know if she was ever going to graduate because it took a long time to process that. When you're in that, I have the end of my dissertation in sight, but she got it done, and she's having the samples shipped from the Strong Heart repository and sent to the person who's run them. So it is possible to do it in a dissertation time frame. I'll use MESA as an example. Whenever you get involved with MESA, whether it be through ancillary studies or publications, you want to make sure that this in particular is talking about ancillary studies. You want to make sure you really understand the mission and what MESA is trying to do with the data that they have available. And particularly with ancillary studies, you're going to get a much smoother process as long as, I don't want to make this sound negative, not as long as you don't interfere with that. But for example, they did collect a lot of blood on all of the participants, and they portioned them out into these little aliquots. So each person has a set number of little vials that they have left. You don't want to go back and ask them for 15 of the 30 vials for somebody, because they're not going to give you they're not going to sell you the whole farm on one project. But as long as you play well in the sandbox and you kind of keep with the mission of MESA, tie it in with cardiovascular disease, or make it known what the link is to whatever you want to look at, you usually don't get much pushback, and they're more than supportive. Some people see the approval processes that are required as a downside. I used to, because it takes a long time compared to when I worked in a lab where we had our data and we could just analyze it, run it, and publish it. We just needed one person's approval. The cohort studies like CRDEB and MESA have a lot of oversight because of all the data they've collected. There's a lot of people involved, and everybody you have to get a lot of different approvals. That includes steering committees, monitoring boards, publications and presentations committees. There's lots of people. However, what you get when I think I mentioned this already, what you get when the paper is finished or when the grant proposal is finally reviewed or whatnot is a much more solid product, because you've had so many people who are leading experts in the field review this for you and collaborate with you on it. So for ancillary studies in particular, there's additional levels of approval that you have to have before you even submit the grant saying you're going to use, say, CRDEB samples. But as long as you don't interfere with the main objectives, don't place undue burden on participants, have the highest, make sure, and they'll help vet this for you, that your questions have the highest scientific method or merits, and you require that that you have to also justify that the unique characteristics of MESA contribute to this being a successful and an interesting research question. Now, this is an example of how you could make this work to further your career, collaborating with these types of studies. Now, there's a couple of people in particular that I work with who I think of as ideal models of how they've used this. The first individual I'm going to talk about is Mike Schlepak from the University of California, San Francisco. He was in the cardiovascular health study. He was a young investigator, and his interest was in renal disease and finding better markers of renal disease. He wasn't necessarily even interested in cardiovascular disease per se, but because they had all of this data collected and urines collected and whatnot, blood markers, he was interested in using these cohorts for this purpose. Not exactly cardiovascular disease, but not too far outside the mark. He started as a non-CHS investigator, but he got in the door by writing a number of papers on renal diseases and renal markers and CVD outcomes in the cardiovascular health study. And once you learn the process for one of the cohort studies, you kind of learn how they all work. And once they see, hey, he's published studies in this study, oh, we can use our data too. And they're a little bit more open once they see that you know what you're doing. So he wrote a number of papers in this area. And once he established himself as in that area, because it's hard to ask for funding when you don't show the funding agencies that you can actually write papers, which are the research currency. If you walk in the door with a few papers in this area that you've already established yourself, you're going to be more likely to get funding. He got funding for an ancillary study to measure cystatin C in the cardiovascular health study. He went on to organize the renal disease working group because there wasn't one previously, so he became the chair of the working group. And in this cohort, because there wasn't a focused research group in this area, he really spearheaded it as a junior investigator and took this as an opportunity to really get himself out there. He brought in more junior investigators because, hey, I'm looking at this, I have time to mentor, and he really brought in people and expanded the number of investigators interested in this area as well as other aspects of the health of CHS. He moved up to be a more senior member of the steering committee, so he became more of a governing body in the study itself, and then he started expanding the work to other cohorts. Now Mike, I would say, is mid-career. So this is something that he's done over like the last 6, 7, 8, 9 years. So it didn't take that long, but he really used this as a great platform. The nice thing also is that the majority of the things that he's doing here, with the exception of mentoring bright young investigators, I'm sure he has to have some face time with them, most of this stuff you can do at home on your couch in your pajamas because everything is remote. So that's the nice thing about me moving to the University of Oklahoma is my population laboratory is my computer and my chair, and I work at home one day, so I hop on the couch in my PJs with the news on the background, and I'm having conference calls and whatever, because all of the data is in a repository somewhere. I get data sets, and all the investigators that I work with are at all these different institutions. So that's one of the nice things about that. As you know, you go to different places, and when I was interviewing for jobs, you know, one of the questions is what can you bring here? Well, one of the things that OU was really excited about, they had Strongheart, but they had nobody that could give them access to, although they could get it on their own, it's not that difficult of a process. They didn't seem to think they had anybody that could help them access these large databases. So now we have graduate students and other investigators in the department who are working on these cohorts. So that was something that gave me a little bit of an up on the job market too. So that was nice. Now Joel Kaufman is a different example. He's at the University of Washington. Now he took a more direct route. He was a non-MESA investigator. And the Environmental Protection Agency released an announcement that they were going to give research funding to people to evaluate particulate air pollution's impact on cardiovascular disease. Okay, so if you're not familiar with the process, when you're looking so as an investigator, you can say, I want to look at this research question, and you apply to the funding agencies and say, please give me money, this is what I want to do. On the other side, the funding agencies sometimes come down and say, hey, we want to find people that are interested in this research question. So that's called an RFA. The RFA came down saying, we want people to look at particulate air pollution's impact on subclinical disease. He was not a MESA investigator, but he spoke with the MESA colleagues and organized the proposal to put in the grant. And without having previously worked with MESA, he secured funding to collect air pollution data in the MESA study, and it's one of the major ancillary studies that MESA's been publishing papers off of. So you can get involved right in the get-go with funding, but you just have to have a major, you know, it's not as easy as when you know them and have worked with them a little bit, but if you really come in the door saying, hey, this is a strong question and we have a good chance at this, they're more than likely to be helpful. Now MESA's ancillary studies, there's 70 plus ancillary studies that have been funded. So we have the main exam where they come in and collect all the basic stuff, and over the years, and MESA's not that old, they've been collecting data, I think they have 8 years of follow-up. MESA's not even that old as far as the other cohort studies, but 70 plus ancillary studies. They've been funded by the NIH, other agencies, industry, local funding agencies. I have a student on campus, or a faculty member rather on campus, who we're putting in a local pilot grant that's funded by the University of Oklahoma to run a couple of samples for pilot purposes in one of the cohort studies. So you can get all different types of funding to do it. Some of the larger ancillary studies are the Share Consortium, which is a genome type, I think Share, or sorry, the MESA family study. So the MESA family is one of them where they're actually looking at additional measures of the people, of the family members of the MESA participants. So familial risk factors and effect on the family members, air pollution, there's a lung function study, a sleep study, and an epigenetic study. So these are the really big funded, the multi-million-dollar funding projects, but then you can get smaller sources of funding also. So how do I get started? If you, first you need to come up with a good idea. But like I said, don't be afraid, don't be sad when somebody else already had the idea and is already working on it. That happens more often than not. But you go to the study websites, and I'm going to walk you through some of the study websites. You want to identify somebody that you see, you're going to see a name oftentimes that'll keep popping up on the same types of papers. Oh, let's talk about, Mike Schlepak is a good example. If you're interested in renal disease, he's probably going to be on most of the papers that come up in Cardia that have to do with renal disease or the markers that he's been looking at. So you might want to contact him, or actually, I mean, I'm more than happy to help you with this process, but you would identify a collaborator, somebody that you want to get involved with, and be sure the idea already isn't being done. There's ways to check if it's already been done, but sometimes you don't know what people are working on. Read and follow all the requirements that the studies have that you need to follow. There's a lot of requirements, but they're very well documented. And then have fun, because this is a great opportunity. I have a lot of students that are working, and they're just so excited to be working on major data sets. So I'm going to walk you through pretty quickly. So I have two data sets, two websites here. I have the Cardia website here and the MESA website. Cardia is doing better over the years at documenting all of the data that they have, but you'd be surprised that they don't have everything in the world that you need to know, but they have the majority of it. So for example, under scientific resources here, you can look at exam materials, and you can go to exam components. This is a list. We have the exam years here. So the year that the exam was collected and the exam number, so year 0, 2, 5, 7, 10, 15, 25. And here on the side are all of the different variables that were collected, and the X will indicate whether or not it was collected at that time period or not. So something like resting blood pressure, you're going to have that at every exam going across. Something like standing blood pressure, only measured once. DNA, we have genetic material and DNA storage. You only have that at certain time frames. Stored cells for cell immortalization, whatever that is. It's only measured at that exam. So you just need to take a look through the exam and see what was collected. And the first thing you need to figure out is yes, no, whether or not something like that was collected. So you can look, there's family history, physical activity, nutrient, obesity questionnaires. We were talking earlier about job and occupational information. So here's, let's see, neighborhood, caregiving, social networks. Just kind of take a look through and see what they have. Cognitive function, pulmonary. Now here's a list of sub-studies also. So this is basically where you start. So for example, we do know, you find that yes, they have some information about something at a given exam. Let's say there's something at exam 7. Go under, you go back, and you'd go under data collection forms. If it's a sample, okay, you're not going to be able to see what they've actually run. You just know yes, no, whether or not they have the data. But if there's something general like physical activity questionnaire, if you want to see what the forms look like, you can go into here, you can look at the exact exam. So let's look at year 7. You can pull up the actual forms that are on there. So I don't know. Let's see if you're interested in anything. Yes, no, they're on hormone therapy and anything other than birth control. You can take a look at exactly what was collected and the name of the variable. So if you have any more specific questions, they're all listed, what the exact variable names are. Okay? So most of these studies will have this level of detailed documentation, but depending on how old they are, MESA and CRDEB are a great example because they've been continually updating their website. Because they have ongoing funding, they have the resources to do this. If you go to a study that's not been funded for a while and they haven't updated their website, you may not find the same level of detail on their website, so you'll just have to do a little bit more digging, contacting people directly, figuring out what's available. Once everything on the website, everything that you need to get involved with or figure out how to get involved is on the website. You can also search the publications. There's a biography, there's a list of all the publications, and you can search the publications. So you can look by investigators, by first author, by co-authors, and by the keyword. So if you're interested in anger, let's look at all the studies that are available, all the cohorts. Well, not a lot done on anger, but there's racial discrimination in skin color and cardia. You can take a look at like abdominal fat. I'm sure there's going to be a lot more of those. Under that keyword, there's only potentially one, but I'm sure there's more. But you take a look and search people in that way. Now, if you're interested in the MESA study, they have some study sites are a little bit different. MESA has an internal website here in the bottom. The MESA site has a password, it's password protected. But if you're interested, I'll give you the information because everybody in the world knows it. The username is MESA. The password is subclinical. Make sure I spelled that right. Okay, so now you're on the internal website for MESA. Again, it's password ID MESA password subclinical. This website, you need an additional level to get into getting access to what was collected when, what variables are available and whatnot. So you're going to see all different types of websites, what they have available, what they don't. Some are in the Stone Age, they have nothing. Some are really up to date and have searchable engines that you can use. So it's going to vary. But I will go ahead and end there because this is just kind of a feeler for where you're going to get your starting information. And I always like to, this is kind of the way that I think about working with the cohort studies. So we can all have the opportunity to sit in the shade today and enjoy all the existing resources because someone planted the cohort tree a long time ago. So we have a lot of data that's yet to be used and lots of opportunities. So I'll thank you for your time, and I'm more than happy to answer any questions that you have right now.
All right, we have about 10 minutes for questions and, I guess, questions.
I have a question. Like, on your slide, you mentioned identify collaborator.
Yes.
You recommend 6 degrees of separation.
Well, let me be clear about that. What I mean, identify a collaborator is one piece. That's something that you have to do. But you'd be surprised at how interrelated and how everybody knows everybody on all these cohorts. So, for example, if you give me a call and you say, I'm interested in this, can you help me figure out whether or not this has been done? I'll look at some of the people on those papers, and I may not know those people directly, but I know somebody who knows them. So I can at very least contact, let's say, the chair of the steering committee on the MESA study and say, hey, can you help me figure out who are the best investigators to rope this person in with? And they'll give you both the on-the-record and the off-the-record answer to that question. The on-the-record meaning, yeah, this person's really good, but he's really busy and you're not going to get a lot of his time. But this new junior investigator, and oftentimes people get sent to me, this new junior investigator is really helpful in helping you get stuff done. So why don't you call her and she'll help you get the processes done, and then once you get things a little bit more secure, it's easier to put a more complete proposal or whatnot under somebody's nose who has a little less time. So identify collaborators, yes, but there's all different types of collaborators that can help you get to where you need to go, if that makes sense. Okay.
So am I understanding this correctly that because all of these samples are coded with this additional information, you can contact someone and you say, I would really like to look at such and such.
Mm-hmm.
And I would like the people that have had an MI
Yep.
and they're under 40 and
Mm-hmm.
they're Native American, and someone will pull just those samples for you.
Yes, as long as you get money to pay them to do it.
Okay.
That's usually the key, right?
Which brings me to my second question, and that is, so these two studies
Yes, so for...
What happens to studies when there's a lapse in funding?
That's a good question. Well, one depends on what type of funding is lapsed, right? Because there's funding for the coordinating center, there's funding for, these are all different funding mechanisms, but there's contracts that keep the coordinating center running. So for example, Strong Heart Study is not necessarily collecting additional information on people, but they still have people who can review proposals, so they don't charge anyone for getting, say, a paper proposal reviewed or an ancillary study proposal approved. Some studies, because they have no funding for anything anymore, charge from the get-go. If you want this to be reviewed, the fee is $100. And, you know, because somebody's got to be doing it, right? So it varies study to study, and it varies on what level of funding they still have or don't have. But the majority of these studies, because NHLBI would probably not let any of the samples be thrown away. They'll move them around, or they'll, you know, keep them. They'll keep them in their possession. The question will be, how do you best maneuver, and who do you contact, and what's the different process for if they're funded or not? So, but again, if you're interested in that, say CRDEB and MESA, who are still ongoing, as long as you get your approval from the study, usually they want power calculations to back up how many samples you need, and if you'd actually see something if you poll that many people. And they want the minimum numbers of samples that you need, of course, because they don't want you to run it on everybody, because they want to keep as many, and they even like it if you can, they'll pull like a half of an ml aliquot for you for so many people, and they'll even request, hey, if you can even send us back what's left over, we'd really appreciate it. And there's also different amounts of samples left depending on the exam. So year 0 for most of these studies is pretty used up. You might start at year 3 or 7, and if you want to do longitudinal analyses, you might have to start at different years. We have a master spreadsheet where we look at number of exams and numbers of aliquots treated in different ways that are available for all the different participants. So if you're interested in something like that, I can get access. I only have that for cardia because I'm working on an ancillary study for measuring something in cardia, but I can get access to that for you and get a copy of it if there's something that comes up.
As far as getting access to existing data, so there we have data on, do you have any idea, is there a ballpark figure for hours, or unless you want to get, you know, a population, you want to get information on inflammatory markers and see the population data that they already have? Do you have
Like a time frame that it takes?
not just time frame, but the cost.
That'll also depend on if they're funded or not. So the reason I talk a lot about CRDEB and MESA is they're still actively funded. It costs nothing to get a data set. It's just, it's more time consuming than most people would expect. You have to write a paper proposal, circulate it to all the people you need to circulate it to. They give you your feedback. It's a lot of sit around and wait. So once you get it to that stage, you submit it. Once you get it approved from the people that are probably the ones that need to see it, you submit it to the Publication and Presentations Committee. They approve it. Once you get approval, they send it down to the coordinating center. That's another week and another week. Then you have to send in a list of variables that you're requesting based on all the forms or whatnot. And then that's another couple of weeks. Then they'll send you the data set. Then usually, oh, I forgot something. I need to ask for another variable or something like that. So it just, it's a lot of sit around and wait. CRDEB and MESA are still free. ERIC is notorious because they're not actively funded anymore. It's very expensive. You can pay $5,000 to $10,000 for a data set depending on what study you need access to. So a lot of people write those into grants to do secondary data analysis. But with many of them, they're still actively funded, or they don't charge for them. So it just depends on what population you're interested in. And oftentimes who you know to see if we can actually get one through the back door.
Are there additional roadblocks for people who are doing basic research who may, say, find something very interesting in their basic research that they may want to see quickly how it translates to the human population? Are there additional roadblocks for people who are not technically doing human studies that
I mean, the only roadblock I can think of is that you sell it that it's a reasonable research question and doable and fundable. So none in particular, but just it would be the same types of roadblocks that somebody that wants to add in doing DEXA scans on everybody would have. Just proposing it.
DEXA scans on your animals, we have the same
Right. It would probably be more of an issue of grantsmanship. How do you sell what you have been done, that you're established, blah, 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 and we'd like to apply for this funding, and this is what we're going to be doing, and show all of your previous work and whatnot, and you just need to get their approval, yes, no. So I wouldn't say there's any additional, but you probably have the same roadblocks as anybody else that wants to measure it with, you know, human that do human research rather than basic.
Just wondering if there's any questions from our remote sites. Okay. Any other questions?
This last, the MESA, you have to put in a username password to get in. What if I get into another one and I need that information? How do I just contact
You can use, oftentimes they have, on the website itself, they have someone, they have some type of information somewhere where you can contact someone. But again, it's off the 6 degrees of separation from Kevin Bacon. I don't think I have my email address on here. But here, what I'll do is I will put it on here so you have it. And if you come across anything, I'm not aware of too many other studies that have password protection.
I feel like the components and the questionnaires and stuff is pretty necessary to develop the questions.
Oftentimes especially when they have something generic listed like, yes, we asked about physical activity questionnaire. Well, did you ask how did you ask? Is it leisure time? Is it occupational? Is it whatever? So a lot of the studies have things fully documented. If you hit a roadblock, you're more than welcome to send me an email because you can contact them directly if you don't get anywhere. MESA is very open to I ask different people to come and talk about things with MESA, and every time somebody comes and talks about MESA for me, they're giving out the password freely. So I'm just kind of doing what they do. But most of the time you can contact them and contact the coordinating center, and if it's no big deal, they'll even send you an email with it. My guess would be if you contacted MESA and not having it, they would just send it to you in an email.
I'm not a card-carrying epidemiologist. I'm a clinician by original training.
We'll forgive you.
But about 15, 16 years ago, I did become involved in public health and prevention and some degree of epidemiology, on-the-job training, so to speak. And it would have been extremely valuable if I could have heard this lecture 15 years ago. And so I think it's very fortunate that the young folks in this room and the middle-aged folks in this room had the opportunity to hear what you had to say. I found it very valuable, very helpful.
Good. Thank you. I appreciate it. And just to give you an idea, the NHLBI, I believe it's just the NHLBI, they fund these things called population studies workshops. I don't know if some people in the room I know have attended them. We've talked about it earlier today, where you have to pay a fee basically to go to these workshops. And the fee is to support the people that they bring in to help expose you to these studies. But for example, they might have one they usually feature 2 cohort studies. I went to one that had ERIC and the Women's Health Initiative study. And they just spend 2 days going over all of the resources that are in the studies, how you get collaboration started, whatnot. It's basically a very long 2-day version of this. And you end up working with the investigators that are on site that come from the studies to help you identify something that has or hasn't been looked at. They help you identify a proposal. So most people walk out of that population. I don't know, did you have that experience? Were they working with you on developing proposals?
Absolutely.
Okay.
So I just went this past summer and they had the Jackson Heart study and the Strong Heart study. And it was free. There wasn't a registration.
Oh, there wasn't? Okay.
You just had to pay for,
Your lodging and whatnot. Okay, well that's good to know.
But it was very hands-on. All of the key investigators from those 2 studies were there. It was very interactive, and the goal was to come up with a proposal at the end of something new and to submit it.
And I attended one of these, but at the same time I was a postdoc on site. It was a competitive process? Okay, that's what there was something about it I knew that was, okay. So you had to, basically your CV and your proposal to...
Right, so you have to do some initial work. They tell you what the 2 studies are that are going to be part of that workshop, and then you have to do some work yourself and come up with a proposal. And then it's
So, and I mean, as nice as that workshop is, there is a lot of things that you can do on your own if you just don't have access to that. So especially master's level students, PhD level students, these are, you know, one thing I will say is that the studies will want the best type of publication or best type of analyses that can be done to answer a given question. So keep that in mind if you're, say, a master's level student and your analytic skills are only maybe at a cross-sectional level, linear regression, logistics, something like that. You might be faced with, well, we want to submit we want to look at this, but Cardia may say, well, that's all interesting and well that you want to look at it at year 25, but we'd really like you to look at changes in this over time or whatnot. So you might have your idea and the way that but they have another idea of what they'd also like you to look at. So how I've dealt with that in the past is I have a graduate student for their say master's level project. They only analyze so much of the data for their project. I help them analyze the rest of the data, or an analyst that I'm working with helps them analyze the second piece of that. And it works as a almost a consulting type situation where the graduate student learns how to analyze real life data sets as well as collaborate with an analyst with more advanced skills. And at the end they present the entire paper. They're the first author on the paper, but they use the analyst and work with them and make sure that they understand and interpret all of the statistics from that more advanced technique in their final paper or MS level document or whatnot. So that might be one of the only obstacles, that you might have something that's more to your level that you want to do, but they may request that you do something a little more complicated, but there's ways to get around it for your own educational purposes.
All right, we're over time. Just want to thank Christina and Bakia, the Department of Epidemiology, the CRDEB for this presentation.
Yeah, thank you.